In this video, we're going to learn how to express two numbers as a linear combination. In order to do this, we will need to use the results of the Euclidean algorithm as shown in the previous example. Here are the results when we applied the Euclidean algorithm to 1751 and 957 in the previous video. Here we found a GCD, or greatest common divisor, of 1. In order to write these two numbers as a linear combination, we will begin by working backwards. We'll start right here, and we'll rewrite our equation so that it is solved for our GCD, 1. So we have 1 equals 16 times 1 plus 5 times negative 3, which is simply a re-expression of our existing statement. Next, let's look at the line above, where we have 21 equals 16 times 1 plus 5. We'll rewrite that so it is solved for 5. So we have 5 equals 21 times 1 plus 16 times negative 1. Next, we will take our expression, which is equivalent to the number 5, and substitute it into the expression above. So now we have 1 equals 16 times 1 plus 21 times 1 plus 16 times negative 1 times negative 3. We'll simplify the expression. So we have 1 equals 16 times 1 plus 21 times negative 3 plus 16 times 3. This becomes 1 equals 16 times 4 plus 21 times negative 3. At this point, we'll be moving to the next screen so that we have more room to work. I would recommend pausing the video and jotting down the work we have so far, as well as checking each line to make sure that it is clear how we are rearranging these expressions. Moving on to the next screen. We left off at 1 equals 16 times 4 plus 21 times negative 3. And I'm going to re-import our results from the original application of the Euclidean algorithm so that you can see the steps as we continue to work backwards. Next, we're going to move up one line and set the equation equal to 16. So we have 16 equals 142 times 1 plus 21 times negative 6. And we'll substitute this for 16 in the line above. So we have 1 equals 142 times 1 plus 21 times negative 6 times 4, since we're substituting this 16 with this expression, and 16 was multiplied by 4 in the line above, then plus 21 times negative 3. Simplifying this expression, we get 1 equals 142 times 4 plus 21 times negative 27. Now we work back up one line in our original Euclidean algorithm, and we set it equal to 21. This gives us 21 equals 163 times 1 plus 142 times negative 1. We substitute our expression equivalent to 21 for 21 in the line above. This gives us 1 equals 142 times 4 plus 163 times 1 plus 142 times negative 1 times negative 27. Simplifying this expression gives us 1 equals 142 times 31 plus 163 times negative 27. Going back to our original work in the Euclidean algorithm, we move up one line and we set that expression equal to 142. That gives us 142 equals 794 times 1 plus 163 times negative 4. We take this expression and substitute it for 142 in the line above. This gives us 1 equals 794 times 1 plus 163 times negative 4 times 31 plus 163 times negative 27. Simplifying this row, we end up with 1 equals 794 times 31 plus 163 times negative 151. Now I highly recommend at each step that you check your work and make sure that you understand how everything is working out. At this point, we're going to move to the next screen. You may want to jot down what we have here and check your work. So now moving ahead, our next step, working our way up in the Euclidean algorithm, is to set our expression here equal to 163. This gives us 163 equals 957 times 1 plus 794 times negative 1. We substitute this expression for 163 in the line above, and this gives us 1 equals 794 times 31 plus 957 times 1 plus 794 times negative 1 times negative 1, 51. This simplifies to 1 equals 794 times 182 plus 957 times negative 151 and finally, moving up to the top row, in our Euclidean algorithm, we set our expression equal to 794, and this gives us 794 equals 1751 times 1 plus 957 times negative 1. We substitute this expression in for 794 in the line above, and this gives us 1 equals 1751 times 1 plus 957 times negative 1 times 182 plus 957 times negative 151, which simplifies to 1 equals 1751 times 182 plus 957 times negative 333, which is our desired linear combination. This concludes our example. I hope you found it helpful. See you next time.